Space is big, like really big. But how big is it exactly? Well, let's put some context into this.
Given our modern abilities of rocket propulsion, we can accelerate a spacecraft to a speed of over 17,000 miles an hour. That's absolutely insane!
You could go around the entire Earth in just over an hour at that speed. And yet, even at that insane speed, it still took astronauts over 3 days to reach the lunar surface. And to reach the Martian surface, it would take over 7 months of space travel.
That means NASA would have to pack about 7 months of food just to get there, maybe a month or so on the Martian surface, and then 7 months back. That's nearly 2 years of food per astronaut, most of which is going to get consumed just in travel. That's like going camping for a weekend and eating most of your food just on the car ride out. This is really good. And obviously, the further out we go, the longer things are going to take. It would take 6 years just to get to Jupiter, 8 for Saturn, and 9.5 years just to get all the way out to Pluto. Not exactly convenient, is it?
But while science doesn't exactly have the answer to space travel at the moment, science fiction does by traveling at the speed of light. But how fast is the speed of light? Well, the speed of light is actually so fast, to put it into smaller numbers, we have to measure it in miles per second. 186,000 miles per second. That's roughly 700 million miles per hour. To put that number into perspective here on Earth, I can't put that number into perspective. So how long would it take to go around our solar system if we could travel at the speed of light?
Getting to the moon, which by the way isn't visible tonight because it's cloudy, so thanks clouds, you ruined my shot. Getting to the moon isn't necessarily a convenient or practical application, seeing as 2 seconds after we set off, we will crash into it and destroy it.
But going further out, at the speed of light, traveling to Mars would only take an average of 22 minutes.
22 minutes is approximately the same amount of time it would take to drive from right here in the Oval all the way to the city of Loveland. But instead of going to die at Fort Collins, we're going all the way to another planet. From there, it's just 46 minutes to Jupiter, an hour and a half to Saturn, 4 hours to Neptune, 5 hours is all it takes to get to Pluto. That's the same amount of time it takes to get from Denver to Orlando.
But what if we wanted to go further out than our solar system and visit other planets outside of what we know, like Proxima Centauri b, which is an Earth-like exoplanet existing within the habitable zone of its parent star, Proxima Centauri? Well, since it's 4 light years away, it would take 4 years to get there at the speed of light. And that may seem like a long time, but comparing that to the 6,300 years it would take to get there normally, I'd say it's fine enough. But what about going faster and further to explore strange new worlds and boldly go where no one has gone before? In Star Trek, there exists a speed known as warp. Warp is actually faster than the speed of light, but only by 282 miles per second. That's like going 5 miles an hour faster on the highway. Sure, it's faster, it's just not that much faster. But thankfully we can go to warp factor 2, which is, you guessed it, 8 times the speed of light. I didn't write Star Trek, okay? That means it's 8 times faster to get to that exoplanet. But what about visiting other galaxies? Well, from Earth all the way to the edge of the nearest galaxy, known as Andromeda, at the speed of light, it would take 2.5 million years to get there. And even at warp factor 2, it would take over 100,000 years to get there. And all the way at warp 9.975, which is the fastest a Star Trek ship has ever gone in canon, 2,000 times the speed of light, it would still take over 1,000 years to get there. That's how far Andromeda is, and that is how small we are.
Now, I'm sure there has been one nagging problem in the back of your mind while I've been explaining all of this, and that's, hey Tom, isn't it physically impossible to travel at the speed of light? And the answer is yes, it is. If we were able to accelerate mass to the speed of light, it would quickly convert into energy and then die. And you can see why that would be a problem. And also, not to mention the fact that if we were able to actually achieve that speed, accelerating from relatively nothing to the speed of light would flatten a human so much so that we would have to measure them at the subatomic scale. And yes, that would kill you. In researching for this particular segment, I was consistently amused by just how all of a sudden traveling the solar system became so within our reach. 22 minutes to Mars, that's insane. But I was also equally amused when I went further out to Proxima Centauri or Andromeda, just how big the numbers got. I was giggling at my calculator, and that might be the nerdiest thing I have ever said in my life, but suffice it to say, it is so fascinating just how truly small we are here on Earth. I mean, yes, years feel significant to us, but on the cosmic scale, we only exist for seconds at a time, and that really makes you think, what really matters? But I guess that's not for me to debate.